Okay, so here we are with our solving exponential equations. There's our giant list of log rules: the fundamental property, special points of the logarithm curve, inverse identities, log base b of b to the x equals x, b to the log base b of x equals x, product addition rule, quotient subtraction rule, power coefficient rule, change of base property. This one is not used much. If you have access to the internet, like GeoGebra, you can just calculate logarithms to weird bases. It's just a hangover from when calculators didn't have those kind of buttons. The other ones are actually all pretty important, and you get used to them as you go through, as you work with logarithms. So we want to be able to solve equations. Let's see if I can focus a little bit. So exponential equations. Some exponential equations you don't require using any logarithms because you can rewrite some of them in terms of the same base. So suppose we want to solve this equation: 7 to the x squared plus 3x equals 1 over 49. We know that 1 over 49 is 7 to the minus 2. And so now we've rewritten it so it has the same base. So what does that mean? This exponent has to equal that exponent. That's just a quadratic equation. We can solve that, move the 2 over to the other side. We look at that and we think a little bit and say, okay, well, that can be factored. 2x plus 2, x plus 1 equals 0. So x squared, 2x plus 1x, that's my 3x plus 2. So x equals minus 2, x equals minus 1. So that's not too hard, right? Don't need to use any logarithms because you can write everything as base 7. This one, you can't write everything in base 2. So it looks like there are different bases because it's an 8, but 8 equals 2 cubed. So 8 to the 3x minus 1 is 2 cubed to the 3x minus 1. But remember, when we're stacking powers like that, you just multiply the powers together. So you get 2 to the 9x minus 3, because you take 3 times 3x and 3 times minus 1. So this is 2 to the 2x plus 3 equals 2 to the 9x minus 3, same base. So that means the two powers have to be the same. Right? And that's not too hard to do. Add a 3 to both sides, subtract a 2x from both sides. X is 6 over 7. So sometimes, right, if the equations are nice, you can solve them without actually doing any logarithms. But sometimes you can't. So you want to be able to solve equations using, by isolating the exponential term all by itself. So the fundamental rule again is that b to the x equals m can be converted into a logarithmic equation like that. But what you have to do is you have to isolate the exponential term. We want to isolate that thing. So what we'll do is we'll start by subtracting 3, and that gives me a 9 on the right side. And then we'll divide both sides by 7, and that gives me e to the 2x plus 1 equals 9 over 7. And now we can use the fundamental rule. Logarithm base e, that's ln, of the number equals the exponent. So at this point, you can do one of two things. You can say, well, I've got a calculator. If we turn it on, 9 divided by 7 is that. The natural logarithm is that, 0.2513. So 0.2513 equals 2x plus 1. So how do we solve that? That's not too bad. 0.2513, there's my calculator, minus 1 So subtract a 1 from both sides and then divide by 2. That tells us what it is. And remember, logarithms are just numbers. On the other hand, I had to do some rounding here, and if you're doing rounding, your answer could be a little off, and we all know that my math lab can be a little upset about that. So can we solve this symbolically? Well, sure, it's the same thing, right? You want to subtract a 1 from both sides. So if we subtract a 1 from both sides, we get logarithm of 9/7 minus 1 is 2x, and then divide both sides by 2. And then if you calculate that using GeoGebra or your calculator or whatever calculational tool you have, you can get a nice exact value for what x is. Okay, but the key point is in solving this kind of an equation is that we want to isolate the exponential term and use the fundamental rule, and then you can solve for x. The fundamental rule gets the x out of the exponent, and then you can solve for it. So suppose we want to solve this for x. Fundamental rule doesn't work here because we've got two different bases. One is 3 and 7. So we'll use the coefficient power rule, which is that log base b of m raised to the r is r log base b of m. Great. So we use the fact that it doesn't matter what base you use here for the TB of these coefficient power rule, and I'll take natural logarithm on both sides. So ln of 3 raised to the 2x is ln of 7 to the x plus 1. As long as I do the same thing to both sides of the equation, I'm okay. Now I've got a power here, and I've got a power here. The power coefficient rule means that these can come out front as coefficients. And now we have the same kind of dilemma that we had before. We could say that, here's my calculator again, logarithm of 3, clear, 3 logarithm is 1.099. And logarithm of 7 is by 7. And after logarithm of that is 1.94, we'll call it 6, 1.946. Right, and now it's just a bunch of numbers. X 2 times 1.099 is 2.198. This is 2.198. X equals 1.946x plus 1.946. Right? And you know how to solve that. We'll move. Trying to do a little calculation here. So we'll subtract this term from both sides. That gives me 0.252x equals 1.946. And then if we divide both sides by the 0.252, we get x is 7.72. Okay. Again, there's some rounding going on here and here, and we want to be a little bit careful about it. So symbolically, how do you solve this? It's the same thing, just keep track that this is a number and this is a number. So rather than plugging in the numbers, what I'll do is I'll distribute the log 7, which is what I did here. So I get 2 times x times log of 3 equals x times log of 7 plus log of 7. I want to subtract this from both sides, and that'll give me 2 times x log of 3 minus x log of 7 equals log of 7. So So just subtracted that side over the other side. And now both of these terms have an x in it. So I can factor out the x. And now divide through. And again, if you want a really accurate answer, take this thing and plug it into computer, and that will into GeoGebra, whatever your calculating device is, and that'll give you somewhat more accurate example than this, which has got some kind of rounding error in it. Okay, so again, fundamental rule can help you solve exponential equations. Coefficient power rule is also useful if your variable is up in the exponent and you need to get it out. The coefficient power rule will take that exponent and put it out front as a coefficient. That can help if you've got two different bases to deal with. Okay, so that's the end of that.